Chris Osburn is coming up to kick off session 1.
Well, good morning. Very happy to be presenting the first session today. And just thank you so much to the OCB SSC and for their support and allowing us to present this session. So I've got here just the co-chairs with me. I'm Chris Osburn. And to start off today, what I thought I'd do is just present a few slides to give some context for what we're going to see today. And the actual overview of what we're looking at here, which is the importance of the terrestrial and marine linkage. And we're going to focus in on tidal wetlands, and that's going to be the main focus here. And this term that you have probably heard, blue carbon. And so in order to do that, we've taken a bit of an approach where we're going to have two plenary talks first. So Ray Najjar is going to speak, and then Lisa Marie Windenmeyers. And so those will give you more in-depth presentations about this issue from a couple different perspectives, and then also set the stage for a series of lightning talks that we'll have after the break. Now, the aim of the lightning talks is to really get into the title of the session, which is what's the state of the art in terms of coastal wetland fluxes. So what are people doing right now? What are ongoing projects? What types of approaches are they using to quantify carbon fluxes in various forms? And we've broken them down into lateral fluxes, exchanges, and vertical fluxes and exchanges, internal cycling and modeling. And then also to point out that there's a poster session associated with this just general session, and you can see some of those posters later today. Okay, so picture's worth 1,000 words, so here's the big picture, the terrestrial marine linkage. This is a Veer's image of the Gulf of Mexico. This is the Mississippi River. You can see the plume here. So really what our focus is going to be is some of these fringing coastal terrestrial aquatic interfaces and wetlands. And the aim of what we want to do today is to sort of look at this in terms of carbon fluxes into and out of these systems, but also to provide some perspective on carbon accounting. And so you're going to hear a presentation on carbon accounting and ways that we can look at and actually sort of quantify the exchanges in these systems. And I think one of the themes that we're going to discover today is that there's a lot of heterogeneity in terms of the magnitude of these fluxes in multiple different carbon pools, as well as heterogeneity in the ways that we can approach this. And so we're going to try to provide an overview and synopsis and a general sense of what that is, but then also hopefully to engage the audience in terms of the lightning talks and what's been presented. So after the two plenary talks this morning, and then after each subtopic for the lightning talks, what we're going to do is work our way into hopefully a very interactive group discussion with you all out here, and then we'll be able to have a real community interaction with this topic. And so just to give you a sense here, these are a couple of images from the Bauer et al. 2015. So I just showed you kind of a block diagram of some of these fluxes, and now here are some of the numbers on top of that. And what you'll notice is that if you look in this little circle here, tidal wetlands, we have fairly large amounts of carbon being cycled through these pools. And if we then take a look at, within this larger cycle here, this is where we're focusing. In terms of what's going on at this interface between the terrestrial and then the coastal marine environment, what we've begun to discover is that this rather small area, so this little sliver here, and this is termed just estuaries from Kai's 2011 paper, but really our wetland, this aquatic terrestrial interface fits within this sliver. And the idea here is that the magnitude of these fluxes are very large. They're not very well constrained, and we're going to try to make some headway here with understanding what that heterogeneity is, and again, some of the variability in that. So one of the reasons that we wanted to try to do this with OCB is the sense that we have this very large amount of carbon that's being exchanged, and as we're getting better at understanding what those magnitudes are, we wanted to place it in context with other environments in terms of global carbon cycling. So if we look at these types of ecosystems that we'll be focusing on, and I should also point out that you're going to hear overwhelming focus on salt marsh and tidal wetlands, very much less about mangroves and seagrasses, although we, of course, note that those ecosystems are of critical importance as well. But then in terms of the stock of this material, that is the stock of organic carbon in these systems compared to the terrestrial environment, we begin to understand, of course, that that interface and those ecosystems are very critical ecosystems in terms of these carbon fluxes. And so that's really the motivating force there. So I want to also get into this term blue carbon. So I imagine the majority of you have heard this term, but if you haven't, just to provide a little bit of context, it's roughly 50% of the CO2 sequestered by Earth's biologic systems is cycled into the seas and the oceans. And so blue carbon is the vegetated coastal wetlands here that we contrast with the green carbon because, as we know, we all like to be very descriptive in terms of where our carbon's coming from. If there are atmospheric people in here, you'll probably say, hey, what about brown carbon? You're not talking about that. Well, we're not getting into every single color, but just focusing actually on the one color, blue. And then it's in this small sliver, the point is there's an enormous amount of carbon that's stored there. Now the issue is that if you look at these coastal systems, we're losing a fair amount of that carbon very rapidly, and that's really the cause of concern. And so another motivating reason behind this session. And so here, this figure just kind of shows coastal salt marsh habitat loss. The yellow is, or the orange rather, is since the 1940s, and the rate, even though has actually has decreased, or the amount in recent times is this fraction here. The point is that we're losing these carbon stores, and at a dramatic rate, and ways in which we can improve the modeling and measurement of this carbon and these fluxes is really the focus today. And so I'm going to end on this slide right here, which really gets to this idea of new methods in different types of carbon fluxes, or in these coastal ecosystems, again, these tidal systems like salt marshes. And it's essential for quantifying this net ecosystem carbon balance. So it's not just the point of trying to understand where all these fluxes are occurring, but putting it in the larger context of the coastal carbon cycle. And so with that, actually, I will go ahead and end. This is the overview. And I want to just give a couple of notes about how the lightning talks will run. So what we'll do is as you can see, there are a number of empty chairs up here. So as we go through each topic, we'll ask the lightning talk presenters to sit up here. And the idea is to have a bit of a panel format where each person will come up and present in just a couple of minutes their lightning talk. And then at the end of that topic session, we'll have a general discussion over that topic. So for example, modeling or vertical fluxes. And so the reason we tried to organize it this way is, again, to give this sense of interactivity with the audience and to make the discussion as interactive as possible. So what we're going to be doing is sort of moving people up and forth and back during the presentation and during this session. But this is the way that we'll go ahead and run it. And then again, just to remind everyone that there are a number of poster sessions or a number of posters associated with this session. Okay. All right. So I think now that's all that I wanted to present, and we're going to have start our plenary presentations.